All right, so moving right along, here we're still looking at the multi-threaded loop 1 implementation. And what if we now want to parallelize or multi-thread the second loop around the microkernel? So let's store this in, let's see, multi-threaded loop 2. All right, we've changed that. Let's see, what do we need to do? We need to move where the pragma statement is. So let's search for pragma. There it is in the routine called loop 1. And we just want to move that to loop 2. And in theory, that's, again, all that we need to do. So let's see what kind of performance we get out of this one. So if we go over here again, we may want to start by double checking that OMP num threads is still 4, and it is. And then all we need to say is make, let's see, empty underscore loop 2 8x6 kernel. Let's go ahead and stick with the 8x6. And it compiles it, and it executes it. And we're now running a little bit larger problem size. For the parallelization of loop 1, we only went up to 1500. Now we're going up to 2000, and still it came back pretty quickly. So maybe something good is happening here. Now, one thing that's important to check is that you're actually getting the right answer. We kind of have started taking that for granted, but you really do want to check whether the implementation gets roughly the same answer as the reference implementation. So I've gone ahead and uploaded the output. And as usual, what we want to do is now change the 0 to a 1. So it now plots the results for the multi-threaded loop 2. And as usual, I like to go to where the graph is. And then let's just click on run and see what comes out. And now we're doing quite well. Now remember, you can't expect this to get better performance than you got on a single thread because we are reporting gigaflops per thread. So what we want is the performance per thread to be roughly the same as the performance of the single-threaded implementation. Now, eyeballing it, what you notice is that you get about 34, 35 gigaflops per thread when using 4 threads, when overall with a single thread our implementation got maybe 57 gigaflops or so. So we're doing okay. This is not bad. It's a good start.